The Antonio Project present dual fuel diesel engine big end bearing temperature monitoring. Hello everybody, see you back in my channel. As you can see, in front of me there are several instruments. So what kind of instrument is this? All of this is temperature sensor. I will start with this one. This one is RTD or resistive temperature detector. And this one is thermocouple. This one is thermistor or thermal resistor. And this one is thermometer. And I'm holding now the infrared thermometer. But at this time, I'm not going to share information about all of this kind of temperature sensor. I will share about wireless temperature sensor based on surface acoustic wave or SAW technology. This sensor used on dual fuel diesel engine for measurement temperature of big end bearing. So how is the animation? Let's start the animation. Wireless temperature monitoring. Dual fuel diesel engine big end bearing of connecting rod can experience rapid temperature change during damage development. Due to connecting rod is rotating, therefore, in order to monitoring the temperature, a sensor which is not connected with any cable is required. Sentry is designed to monitor the temperature in these bearings and to give immediate temperature response to the monitoring system, avoiding fatal damaging of the engine. Connecting rod assembly are as follows: connecting rod upper, big end bearing, sensor with antenna, stationary antenna. Sentry sensor can be installed connecting rod without any cable, no active electronic in sensor, no battery, no slip rings. This is the advantage of this sensor. It is wireless sensor, can be mounted on rotating part without interfering its function. Sentry GB200 wireless temperature monitoring. Following is the part name of Sentry GB200 wireless temperature monitoring. The main parts of the system are the temperature sensor, the stationary antenna, and the signal processing unit or SPU. Sensor consists of adjusting bulb and antenna, where the antenna is covered by black color plastic lid. Stationary antenna consists of antenna covered by black color plastic lid, coaxial cables, bulb, and spacer ring. The spacer ring used for adjustment of the gap between sensor antenna and stationary antenna. The bolt is used for fixing the stationary antenna to the bracket. Sensor assembly. The temperature sensor assembly consists of dish-shaped antenna, coaxial cable, and surface acoustic wave or SAW sensor. The sensor and coaxial cable are placed in a cylindrical steel sensor casing filled with epoxy. The antenna is placed in a steel housing and protected from the environment by a plastic lid. For explosion-proof application, the plastic lid is of static dissipative material to prevent electric charge build-up. Working principle. Working principle of the wireless temperature monitoring. The function is based on the surface acoustic wave or SAW technology. The output signal is determined by measured area absolute temperature. The signal processing unit generates a low energy and high frequency radar pulse, which is transmitted to the wireless sensor via the stationary antenna. When the wireless sensor passes the stationary antenna, it is hit by this radar pulse and immediately reflects a pulse back to the signal processing unit. The temperature of the sensor uniquely determines the shape and characteristics of this reflected pulse. A software algorithm then calculates the temperature and transmits this to the engine monitoring and control system. Installation position. The installation of stationary antenna related to the internal antenna of wireless temperature sensor is extremely flexible and non-critical. The angle position between the antennas should be maximum 20 degrees. The lateral position within the antenna should be maximum 5 mm. The gap between the antennas should be 17 plus minus 3 mm. The maximum antenna air gap is also limited by the signal cable's length. Working position. Installation on the engine side. The temperature sensor is mounted on the connecting rod close to the bearing cell's backside. The stationary antenna is mounted on a bracket fastened to engine block or crankcase cover, and the signal processing unit is mounted on the engine block. The cable gland connects the inside stationary antenna cable with the outside coaxial cable going to the signal processing unit or SPU, and the shielding of the coaxial cable to the engine potential level. The signal from SPU then transmitted to the monitoring and control unit. The sensor's radio frequency or RF pulse excitation is transmitted via two antennas, one in stationary antenna and one in the temperature sensor mounted on the connecting rod. The RF pulse transmission to the sensor and the output signal reflection from the sensor take place when these two antennas are within a set distance of each other. The sensor signal is transmitted from the stationary antenna to the SPU via a coaxial cable. The SPU calculates the absolute temperature and sends the information to the external alarm and monitoring system as a CAN open or an RS485 Modbus digital signal or optionally as a 4 to 20 mA output. RF transmission can be transmitted only during both of antennas is in range, but since engine RPM is 720 RPM, then the temperature indication is continuously monitored. The minimum RPM is set to 300 RPM. Setting is 50 to 60% lower than the minimum allowed RPM on a running engine. For the setting and calibrating the sensor, please watch my next video about calibration of big end bearing temperature sensor. I think that's all my brief explanation about Sentry GB200 wireless temperature monitoring based on surface acoustic wave or SAW technology. If you want to dig deeper about this sensor, please watch my next video. This is about how to calibrate big end bearing temperature sensor. Anyway, if you think that my video or animation is useful, don't forget to click like and subscribe button. Your contribution by subscribing my channel is highly appreciated. This is for development of my channel. See you in my another video. Thank you for watching. Bye bye. If you have any question or advice, please leave it in the comment below. And don't forget to share to others. Sharing knowledge is priceless charity. The Antonio Project.